Good morning, Math 30-2 students. So this week we're going to continue with our permutations and combinations unit. We're going to look at lessons 4, 5, and 6. Take note, there is going to be a little bit that we just kind of like skip through in the workbook. There's some unnecessary investigations and cases that I'm not going to worry about, just considering with the amount of time that we have. So let's look at our first lesson for this week. We're going to look at lesson number 4, permutations with repetitions. So this is on page 87 of your workbook. If you want to make sure that you're following along. So page 87. Now, like I said, we're going to skip this first investigation here, this part 1. I'm not even going to worry about going through this, and I'm not going to worry about part 2 on the next page. I'm going to go straight to the definition and the formula that they give us when we're having to find the number of permutations with repetitions. So I want to bring your attention to this part right here, this really important box. So it says the following formula gives the number of permutations when there are repetitions. So what does repetitions mean? That means repeating letters, repeating items. So it says the number of permutations of n objects, where A are the same of one type, B are the same of another, and C is so on. It can be represented by the expression below. N factorial divided by A factorial times B factorial times C factorial. This will make a lot more sense once we actually start to do an example. But this is, instead of doing a whole investigation part, I just want us to worry about this. So remember, to find the number of arrangements of n objects, it's simply just n factorial. But what you have to be careful about is if there's ever repeating letters, you have to make sure that you divide by however many are repeating. So look at example number 1. It says find the number of permutations of the letters of the word Vancouver. So if we were writing a diploma, I would be telling you right now that this is always a diploma question. So often there is a diploma question where it's simply just asking, how do you arrange these letters? And they're trying to make sure that you can pick out that there's repeating letters. So this should be a question that you're going to get 100% on. So if you look at example number 1, A, Vancouver, what can you see? Well, I can see that there's repeating V's, and is there anything else? No. So all you have to do is you're going to use this formula. So your numerator is, what are the total number of letters that we're arranging? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be equal to just 9 factorial divided by, there's just one letter V which is repeating. How many are repeating? There's 2 of them. So this is where we would use, say, it represents the A. So this would be divided by 2 factorial. Okay, so there's 9 in total that we're arranging, and then there's 2 V's that are repeating. This is where we get the n factorial divided by 2 factorial. And then all you have to do is type that into your calculator, and once you do, you get 181,440 different permutations. Okay? Look at B, mathematical. So same thing, what jumps out at you? Repeating letters. So I can see there's M's that are repeating, I've got A's that are repeating, and what else do we have? We have T's that are also repeating, and that's it. So use this formula again. So how many letters are there to arrange? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 factorial divided by, okay, let's look at the M's first. How many M's are repeating? There's 2, so this would be 2 factorial. Look at the A's. How many A's are repeating? There's 3, so then this would also be 3 factorial. And then lastly, T's, there's also 2, so then this would be 2 factorial. What I would recommend you do is make sure you put brackets around everything in the denominator, because if you don't use brackets, you might get a different answer. So again, you just simply plug this into your calculator. When we plug this into our calculator, we're going to get 19,958,400. And it's as simple as that. So just make sure if you're finding how many permutations of a letter and there's repetitions, just always divide it by however many of that letter are repeating. Okay? Now we're going to look at example number 2. It's another repetition question. It's just not given to you as nicely as just showing you a word. Okay? So this example says Brett bought a carton containing 10 mini boxes of cereal. There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Pops, 1 box of Shreddies, and the remainder are Raisin Bran. It says over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning. How many different orders are possible if on the first morning he has Raisin Bran? Okay, so I always like to write things out, especially when they give it to us in words. I like to visualize. So I'm going to write out that there are 3 boxes of cornflakes. So I'm just going to go 3 CF. There's 2 boxes of Rice Krispies. There's 1 box of Cocoa Pops. There's 1 box of Shreddies. And then the remaining is Raisin Bran. And how many days are there? There's 10. So 3 plus 2 is 5, 6, 7. And then the first day he's planning to eat Raisin Bran. So then that leaves only 2 Raisin Brans after day 1. So 2 Raisin Bran after day 1. Okay, so because I have multiple boxes of the same type, so 3 cornflakes, 2 Rice Krispies, this is actually a repetition question. So we treat it the exact same as if we were organizing the letters of a word. So again, think how many boxes are there to organize? So 3 plus 2 is 5, 5 plus 1 is 6, 6 plus 1 is 7, 7 plus 2, there's 9 in total. So this is going to be our numerator. 9 factorial divided by how many are repeating of each. So we've got 3 factorial times 2 factorial. I don't have to worry about the Cocoa Pops or the Shreddies, and then another 2 factorial to represent the Raisin Bran. Okay, you just simply plug this into your calculator. When we do, we get 15,120 orders are possible. Okay. So that's the first part of our repetition lesson. Now we're going to look at what we call pathway questions. So we're going to look at the next page, and these are going to be linked to what we've been doing with repetitions. So it says exploring roots using permutations and patterns. So same thing, I'm not going to worry about this whole investigation part. What I want you to look at is these are the types of questions we're going to be doing when I refer to a pathway question. So what it means is they give you some kind of a rectangle and they say, okay, how many different ways or how many different routes are there to go from A to B? How do we do that? So there's a couple of ways that we can do it. The first way we can do it is we can just simply do it by hand, which I would recommend everyone learning how to do it by hand, because if we don't get a really nice, perfect rectangle, we have to do it by hand. We can't just use our repetition formula. So what we do is step number 1 is you, on the outside, you're going to label each kind of like tick or where the lines meet with a 1. So 1's all on the outside. You do it on the top and you do it on the left-hand side. Okay, so that's step number 1. Then all we have to do is we're going to be looking diagonally and you're just adding the numbers. So what's 1 plus 1? It's 2. And you put it down in the bottom right-hand corner. Now you move on to the next row and now you take this 1 and you add this 2. What's 1 plus 2? It's 3. Okay, once you've done that column, now move on to the next column. So here again, we're going to add 2 plus 1. What's 2 plus 1? It's 3. Okay, now add 3 plus 3. What's that? It's 6. Move on to the next column. So now we've got 3 plus 1, which is 4. And then I've got 6 plus 4, which is 10. Here's my final answer. So we would say there are 10 different routes. So there's 10 routes to get from point A to point B, okay? So that's how we do it by hand. But because this is what I say, a perfect rectangle, we can use the repetitions approach. So I believe if we look in part B here, they're going to talk about the repetitions approach. So it says, Catherine developed a quicker method. She realized that travel from A to B involves moving 3 units east and 2 units south, and that the answer to the problem is the number of ways in which this can be done. So what I want you to do when we do a repetitions problem is think, okay, how many total ways are we going to move? So I'm going to actually just redraw my picture down here since I've written all over it up there. So it looks like this. So we go from point A to point B. And think we always have to move closer to B. We're never going to move backwards. So we're going to go to the right and we're going to move down. So we need to count how many total movements are there. That's going to be our numerator. So the total movements are going to be 1, 2, 3, 4, 5. So that's going to make up the numerator. So this is going to be equal to 5 factorial divided by. Now just think how many movements are repeating. So what they're using is they're using north, east, south, and west to represent what's repeating. So these 3 arrows to the right, this is like I'm moving east. So this is east, east, east. And then my 2 arrows moving down is like I'm going south and south. So think of it as repeating letters. So in total there's 5 factorial, divided by, this is going to be 3 factorial, times 2 factorial. So that would be the formula that I'm using. And when you plug this into your calculator, you get the same answer, which is 10. Okay? But make sure you guys know you can only use this formula if it's a perfect rectangle. So only if it's a perfect rectangle. If it is not a perfect rectangle, we can't use the repetition approach. We have to just do it by hand. Okay? So we're going to do 2 more examples on the next page. So here's example 3. So it says, a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. Determine the number of routes possible if the bus must always move closer to the concert hall. So we're going to do it by just doing it by hand, and then we're going to do it by using the repetition approach. So you'll also notice in this question, there's actually 2 rectangles that we're dealing with. So we're going to work in the first rectangle, and then I'll show you what you do when you get to the bottom. So step number 1, outline your top and your left-hand side with 1s. Okay? Now you're just always going to be adding diagonally. So what's 1 plus 1? That's 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. Okay, continuing on to the next column, 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Move to the next column, 3 plus 1 is 4. 6 plus 4 is 10. 10 plus 10 is 20. 20 plus 5 is 25. Now, when you get to the bottom of this rectangle, okay, let's call this point A, just to refer to it. So let's call it point A. So how many routes are there to get from the bus station to point A? There's 25, okay? So once you get to this point then, instead of outlining the outside of your second rectangle with 1s, because technically there's not just one way to get there, there's 25 ways to get there, that's what you're now outlining it with. So you're going to use 25s. Okay? Now we can add again. So what's 25 plus 25? And I actually think, sorry, looking at my book, that I've made an error. So let me just quickly look back. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Oh, 10 plus 5, sorry guys, is 15. So I just need to fix these numbers. Okay, so 1 plus 3 is 4, 6 plus 4 is 10, 10 plus 10 is 20, 20 plus 15 is 35. So, sorry guys, instead of 25, it's 35 roots. So now on the outside, you're going to label it with 35s. Now I can continue to add. What's 35 plus 35? That's 70. What's 70 plus 35? That's 105. 70 plus 35 again is 105. And 105 plus 105 is 210. So we would say there are 210 roots. Okay? Okay, so now how can I use my repetition approach to solve this? So I'm going to write out in words what we need to calculate. So we first need to figure out rectangle 1. And then we would continue with rectangle 2. So we would take the roots in rectangle 1 and, I'm writing the keyword and here, and we would take what's in rectangle 2. So remember, in math, what does and mean to do? What operation? We're going to multiply. So for rectangle 1, we need to figure out what's the total number of movements we're going to make. That's going to be 1, 2, 3, 4, 5, 6, 7. So this would look like 7 factorial divided by, how many are going to be repeating? There will be 3 to the right, so 3 factorial, and 4 down, so 4 factorial, and I close the bracket, okay? And then with the word and, I'm going to multiply by, how do I calculate rectangle 2? So how many movements are there in total? There's 1, 2, 3, 4. So that's 4 factorial divided by, I would move 2 to the right, 2 factorial, and I would also move 2 to the bottom, which is also 2 factorial. Okay, and then when you type these into your calculator, you are also going to get 210 roots. So you would get the same answer. Okay, it's totally up to you. If you like to just do it by hand, that's fine. If you want to use the repetition approach, you can do that as well. Okay, now if we look at the last example, example number 4, it talks about a taxi company is trying to find the quickest route during rush hour traffic from the train station to the football station. So part A says, use patterns to determine the number of different routes that must be considered if at each intersection the taxi must always move closer to the football stadium. Okay, so what do you notice about this picture? Are they perfect rectangles? They are not. So we cannot use the repetition approach. So we have to just do it by hand. So I'm going to outline everything with 1s on the top and then 1s on the bottom. But I want you to pay attention to these kind of odd edges once we get to the end of them. Okay, so add 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Next column, 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Okay, next column, 3 plus 1 is 4, 6 plus 4 is 10, 10 plus 10 is 20, 20 plus 15 is 35. Now, I need to take this 15, you guys, and I now bring it to the bottom here, because there were then 15 ways to get there. So then what's 35 plus 15? We're going to get 50. Okay? Now if I go to the next column, I don't have a 1 on the outside, but at this point there were 4 ways to get there, so then you also bring the 4 over to the right here. Okay, so now continuing to add, 10 plus 4 is 14, 20 plus 14 is 34, 34 plus 35 is 69, and 69 plus 50 is 119. So the number of different roots are 119 roots. Okay, so with these oddly shaped rectangles, just make sure once you get to an end, if you need to bring that number down, you can. So for example, we brought that 15 down and we brought that 4 to the right. Okay, And then in part B, it says explain why the permutations with repetitions formula 9 factorial divided by 4 factorial, 5 factorial cannot be used. Well, let's look. How many total movements would there be? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct in that there's 9. And then they're saying 4 factorial and 5 factorial. So there'd be 3 to the right. So 1, 2, 3. And then they're simply saying 1, 2, 3, 4, 5 down. So it doesn't work because it's not a perfect rectangle. Okay, so they're saying 4 factorial. I said 3 because there's only 3 directly to the right. So we're just going to simply say can't use it because they are not perfect rectangles. And there you go. So there is our first lesson looking at repetitions with letters and objects, and then looking at our pathway questions, whether you can use the repetition formula or if you have to just simply do it by hand. Okay, so you can work on the homework for this lesson now.